Welcome to this episode of the Common Sense Skeptic. Recently, we were given the honor of being invited into a discussion with a panel of experts in the aerospace industry hosted by the Coalition for Deep Space Exploration, in the first of what we hope are many more similar talks to come. That premiere talk went a little long and the Q&A got cut short, so we reached out to the organizer to see if we could arrange one-on-one interviews with any of their experts, and we are very pleased to hear back from Jim Mazur, one of the most sought-after aerospace engineers of our time. He made himself available for a one-on-one, hour-long interview that turned into almost two by the time we were done, and we covered a lot of ground. Jim is currently listed as the president of the American Institute of Aeronautics and Astronautics, a position he has held since 2016, and he was selected by Space News in 2011 as one of the top 10 people who made a difference in space. So maybe we'll start with the bullet points from your resume, Jim, and go from there.
I guess I have a fair amount of experience. I started out working for McDonnell Douglas. I thought I joined the Delta rocket program, and Reagan was president at the time, and I immediately got put on Star Wars, working 6 to 7 days a week. We built 3 rapid prototype satellites in 6 years. And so that's where I kind of got hooked on velocity. I did end up working Delta rockets and helped architect the evolution of Delta 2 through Delta 3 to Delta 4, became chief systems engineer of Delta 3. Boeing had bought McDonnell Douglas, went on to be chief systems engineer of Sea Launch, became president of Sea Launch. In that time frame, got to know a guy named Elon Musk who wanted to start a rocket company, and we started talking to each other, and eventually he made me the first president and chief operating officer of SpaceX, and then went on to become president of Pratt & Whitney Rocketdyne, and that's where I really got heavily into human space flight. Eventually went to Pratt & Whitney, ended up running the F-135 jet engine program, and then eventually came back and ran the space business for Aerojet Rocketdyne. So I tell people I have trouble holding a job.
Well, it sounds like you get headhunted a lot is what it sounds like. That's always a good position to be in. Now, you're also a member of the Coalition for Deep Space Exploration. Could you give us like the mission statement of that organization and maybe their elevator pitch roadmap for how to expand humanity out into the stars?
They have a website, and as a member, as part of Aerojet Rocketdyne, of course, I stay tied in with them. Basically, their vision is to be a preeminent industry advocate for sustained human space exploration, science, and space technology leadership by the United States. And they have some guiding principles, but it's really about advocating for, I talk about consistency and constancy of purpose in deep space exploration. And what it's not doing is necessarily advocating for one approach over another. So it used to be the Commercial Spaceflight Federation, and they recently rebranded themselves as the Commercial Space Federation. They have been out in very strong ways lobbying for commercial solutions to everything. What I would argue they might disagree with, to the exclusion of everything else. And what CDSE is about is the focus on deep space exploration using all avenues and approaches available, is how I'd characterize it. So it's not really either or. And you talk about old space, new space, or commercial and traditional. What CDSE is out there trying to do is balance the conversation about there's multiple solutions, and the solution's an and solution, not an or solution, is how I'd characterize it. And whatever's the best. And eventually, as commercial becomes more and more successful, then certainly that would be the avenue to go. But I would certainly argue that it's nascent in low Earth orbit, and extending that model to the moon and Mars today is probably not appropriate.
So we were part of the panel audience from February 28th. And one of the things that you said that really kind of resonated with me was along the lines of we can't abandon proven technology in favor of projected technology is pretty much how you put it. Could you expand on that a bit?
I think the soundbite I have in that is, why are we developing technology to go to the moon when we already have technology to go to the moon? Has already been proven, obviously, instead of developing technology to stay on the moon. So there's a lot of time and energy going to developing new technology just to get and land on the moon. And that is taking a lot of time and money. And I would argue time and money away from staying on the moon. I think these technologies that are in development could eventually become the next technology to getting to the moon more efficiently. But I think as a nation, it's more important for us to just get there and figure out how to stay on there for longer periods of time with a little bit more focus. The other part of that discussion is technology development tends to be sporadic and unpredictable. A lot of technologies with enough time and money can be made to work, but the question is it worth the time and money for that versus the alternatives you have? And some just doesn't work out. And so I think the lessons that have been learned in the aerospace industry and certainly the space industry over time is doing a development project that relies specifically on significant technology development means it's going to be very hard to deliver that project on time and on cost. In fact, it's rarely delivered on time and on cost. And that's what eventually led to, the concept of TRL or technology readiness level. And the concept is from very immature technologies or at like 1 or 2 to very mature technologies at 9. If you're doing a development project, depending on the complexity of that project, you want to know what technology is going into that project and its technology readiness level. And typically anything below 6, people would not want to implement into an overall system that also requires development. I would say right now there's a number of technologies being developed that are below TRL 6 that are required to get to the moon. And I would argue that's not an appropriate direction if we want to get there in a certain time frame.
Yeah, Marcia, during that panel, I think it was her that mentioned that TRL, certain systems somewhere between 3 and 4, which is still breadboard testing, is how she referred to it. So it sounds like if you were in charge of a lunar landing program, you would have picked up where SP-287 left off. They had the roadmap from Apollo, and they had all the redundancy and all the testing procedures, and they laid it all out. And there's a wonderful roadmap. In your estimation, or in your view, why didn't we just pick up from there?
That's a good question. I will tell you, in my last job is basically the president of the space business of Aerojet Rocketdyne. I had SP-287 as mandatory reading for all my direct reports, and I'm sure they flowed that down to their people because I think, the key thing about, high tech activities is to build on what your predecessors have done as opposed to starting over and finding a new path. And why we haven't gone down that path, I think there's a number of different reasons. There's this huge push towards commercial can do everything. And the sort of concept that NASA has become irrelevant, which I think is extremely flawed thinking, other than NASA can provide money to the commercial companies. And I think that's really flawed thinking, but it's been a push to really don't do anything in traditional methods. And so the way Apollo was done was considered to be sort of this monolithic whole of government approach to getting to the moon that was considered to be very, for some reason, very inefficient and very expensive, which I think in comparison, we can see was actually quite efficient. And at the end of the day, in today's dollars, relatively cost competitive for what's a very hard mission. So I think there's just been a push to move more and more towards this commercial approach. And one of the things I observed, and we created a chart that obviously I don't have access to anymore, but it showed everything what NASA was doing. And to get to the moon and stay on the moon, you certainly have to have the launch vehicle to get there. You have to have a lander that can go to and from the moon. You have to have the capsule. You have to have spacesuits. You have to have power. You have to have communications. And NASA's pursuing all of those. And in most of those aspects, with sort of commercial firm fixed price contracts, but also with multiple contractors. So for any one of these aspects, they may be under contract with, 2 to 4 contractors in each of those various different elements. And the contrast I would use to compare it to Apollo was extremely focused, mission focused, with one architecture ultimately and one approach and one series of tests to get there. And when I look at our approach to the moon today, I would call it very diffuse. There's many different architectures being pursued simultaneously with many different contractors. And so the concept is well, this is competition, this will merge, this will be the most cost effective. But I would say if we look at our progress to date, it's not clear that that approach is superior.
Well, no, we have Starship that had the first and solo option A before that was readdressed after the explosion of IFT-1. So what you've got with that program, from what we can see, is a complete abandonment of all other processes, supply chains, materials testing, all of it. Like just completely throw out everything that we learned in Apollo, everything that we learned in Shuttle, and decided to take their own route. And then with that, submitted the lowest bid, for which they've already burned through most of their money. They burned through, I think it's 2.6 billion of their 2.9 billion total fixed firm. So I asked the question during that panel, what happens when SpaceX runs out of money? And can you share with us the answer that you gave?
Yeah. So my answer is my assumption is that SpaceX has access to unlimited funds because that's been the case to date. So you just have to assume that that's going to continue into the future. I think NASA and its nations should be considering the possibility of running out of funds, whether they'd have to make up for if that option becomes more challenging. But my assumption is that they're going to continue to get the funds they need to continue through this activity. But what the variable then becomes is time. And so as we look what's been going on relative to what was signed up for contractually, this is taking way more time. And in fact, the latest series, there's been 8 test flights now. And if you look at the progress that's going on, it's clear that the time is definitely extending. They don't usually tell you the true projected time as you look at a progress today and it gets leaked out incrementally and we're starting to see this incremental slip typically a year at a time of what's really going on with the program. And I think one of the most challenging things with where we're headed right now for the baseline system is all of this test activity to me appears to have nothing to do with landing on the moon. And so we're supposed to be working on a lander to get to the moon. Ideally the goal was 24. The backup plan was going to be 27. It's looking like 29. And I think, given what's going on, that's likely to slip out. And then the question is okay, how much time is this going to take? And does this nation have the luxury of that time?
So when you were at SpaceX, you're involved with the Falcon 1 or Falcon 9 program? Falcon 9, right? Because you had something to do with them landing commercial cargo.
Yeah, it was both Falcon 1 and Falcon 9, but I spent a fair amount of my time there on Falcon 1 after the first mission failure. And I worked fairly hard with the team and DARPA on the failure investigation. And we got to root cause relatively quickly, and it was relatively simple. And then Falcon 9, what I was really focused on with Falcon 9 is I went around and talked to the various organizations. At the time, Elon was not a fan of schedules nor systems engineering and integration. And I understood that to some degree because in the larger companies, both of those activities become extremely bureaucratic and extremely cumbersome, is how I'd characterize it. To get into excruciating levels of requirements and flow downs. And, the saying was, you're ready to go to the moon when the paper's higher than it is from here to the moon, basically. And so that general perception, I definitely could understand. But my experience told me the core of those two activities were certainly value added, but you had to keep them from becoming bureaucratic. And so the concept I came in with was sort of this concept of bringing a little bit more of, at the time I called professional management, sort of getting out of the garage and into a more professionally managed approach, which required some schedules and some system engineering and integration activity without the bureaucracy, maintaining your innovative spirit and approach and velocity, but getting a little more discipline into doing the job, which is really required when you're in the space business. And so as I was working on Falcon 9, I put together some high-level schedules that were very disconnected from what everybody was saying and certainly what was being promised. And that created a source of friction, is how I'd characterize it. But it did highlight the areas where we could see documenting what people are doing and how they flow together in what was called a tier 1 schedule, that we weren't working as efficiently as possible and came up with some ideas to work better. But in that time frame, it became clear to me that my approach to these development activities was different than the path Elon wanted to take. And at that time, Pratt& Whitney had bought Rocketdyne from Boeing and had offered me a job running that business. And so that was a great opportunity. I hadn't done much in human space flight, and Pratt& Whitney Rocketdyne and Heritage Rocketdyne had a ton of experience in human space flight all the way back to Apollo. And that was really intriguing. So I went and took that opportunity.
Yeah, that sounds like a good move. The development program's interesting because we've had, on top of just the hops for Starship, so 8, 9, 10, 11, and they all either caught fire and or blew up, and then 8 IFTs. The explosions of Starship are excused by the followers of Musk as being iterative development. Could you explain the difference between the development of Falcon 9 and Starship and whether or not you would consider the development of Falcon 9 iterative?
Well, as I said, I was involved very early in Falcon 9, so my only observations of Falcon 9 were from the outside. But the iterative approach is basically around a concept, rapid iteration, rapid testing, rapid failure, and rapid learning. And I've always felt time is money, and the fastest approach is usually the most cost-effective approach. And so the faster you can go, one, just the benefit of time to get to market and that sort of thing. And two, I truly believe at the end of the day, it costs less. And in many cases, you can, particularly in the engines, be able to change things out and iterate on the engine design relatively quickly, get it into test, and get real empirical data to learn from and make fast adjustments, rather than using a lot of excruciating analytical tools that are really approximations of reality and then getting in and finding a failure later. So this sort of iterative approach, rapidly iterating a design, rapidly testing, rapidly getting results and making adjustments, I think is appropriate in many cases at the right scale. In the old days, we used to have a process, it's called test, fail, fix. But over time, our experience, first of all, in getting to space and flying in space, and our tools became much more advanced and much more sophisticated and a much better representation of reality. So there's this sort of dichotomy of how much do I test, fail, fix, and how much can I actually analyze in and minimize the failures I have and get close to the final solution in initial development testing. So there's different philosophies and approach, and I think there's sort of a Goldilocks spot there between testing, failing, learning, and making adjustments, and doing a lot of excruciating analysis and still failing. And on the other hand, having a lot of really big failures that cost a lot of money and ultimately time. So I think the answer is somewhere in between, and I think certainly what's going on in the industry today, we're seeing all ends of that spectrum.
I suspect that if the first 8 Falcon 9s had RUD'd during that program, that there would have been a halt to the program or the program would possibly have been canceled. Is that a fair statement?
I don't know. This comes back to typical businesses. I've been Delta 3 failed in its first launch, and I was put in charge of the failure investigation. And its existence was at stake, and it had a failure on its second launch in the upper stage engine, and that pretty much doomed Delta 3 with a shift to Delta 4. C launch, when I was chief systems engineer there, it failed on its third flight, and it was clear to us that not only did we have to have a good failure investigation, we had to convince all the insurance community, both international and domestic, that they felt we understood the problem. They were willing to insure the next launch. And if we couldn't do that, we would be out of business. So well, in businesses that have a profit motive, and a lot of businesses have to have a profit motive, the room for failure is relatively small, and the patience for failure is relatively short. When you have unlimited access to funds, then you have the option for failure because your business case doesn't necessarily depend upon it. So I think that's where it comes back to. I think in a traditional profitable business, a number of failures in a row can doom that particular activity. Either it'll get internally canceled by the business because the business case isn't closing, or your customers will walk away from you or even terminate it, depending on the types of contract you have. When you're self-funding, the tolerance for failure is obviously much, much greater.
Yeah, that's kind of what happened with Deer Moon, right? Where the schedule just kept getting pushed and pushed and pushed, and there's no light at the end of the tunnel. So the client said, you know what, I'm done waiting. So that bit of conversation opens up a bunch of different avenues that we can go down. But first, you mentioned Sea Launch. And as the former president of Sea Launch, what was your take on the TED Talk where Gwen Shotwell was talking about setting up redesigned oil rigs off the coast of every major city and delivering people by rocket 100 at a time in 45 minutes or less?
I mean, Gwen, come on. This is awesome, but it's crazy, right? Like, this is never going to actually happen.
Oh, no, it's definitely going to happen. This is definitely going to happen.
How? Like, what?
Yeah, well, I can't speak to the timing, but the concept of sort of fixed launch platforms off the coast, I think does make a fair amount of sense in terms of being able to sort of rapidly create infrastructure and deploy it to where you need to. I think there's quite a bit to be said for that model. And in fact, with Sea Launch was probably the largest. Well, I mean, if they're going to do Starship, it'd be a much larger scale. But up to this point in time, Sea Launch has been one of the largest scale platforms of its kind, launching a very large rocket. And it was a mobile launch platform. So we had home port in Long Beach, California, and we had the launch platform and we had the command ship. But for every launch, we had to integrate the rocket with a satellite at home port and then travel to a fixed launch site, which was on the equator, almost directly south of the main island of Hawaii, launch from there and then come back. So the logistics of going to a launch site and coming back created, a limitation in just the number of launches you could do per year. And in my mind, created a number of inefficiencies. So we actually did study quite heavily the concept of permanently mooring the platform off the coast from somewhere near the equator. And that started to make a lot of sense so that, the platform was purpose built. You could make multiple of these and put them around the world, but being not too far from a coast helps quite a bit logistically, is how I'd characterize it.
But you wouldn't recommend that as a replacement to commercial air flight then?
No, and that's one of the things I was thinking about too, is just trying to figure out, perspectives on the space business. I think space is so different from anything anyone has a feel for. It's fairly arcane. The physics are actually quite complex. And then we have all these science fiction movies too, where, I'm a huge Star Wars fan, right? This concept of hopping into, an X-Wing fighter and jumping in, taking off, going out of the atmosphere, and all of a sudden going, it's beyond the speed of light is really, really fascinating, but no one has a clue how to do anything even close to that. But people see this kind of science fiction, and the best analogy people can make to space flight is the aircraft industry. But the airline industry and aircraft industry is very, very different from a physics standpoint. From a safety standpoint, also very challenging. And then the thing that the people want to naturally extend is an economic standpoint. And so, the whole concept with the airline industry is taking people and products to places where they are heavily desired, ultimately faster and at an affordable cost. And when you think about space, where are we taking people and products and what are they going to do there? And what are the economics of that? And so this is one of the things where right now there's sort of this fledgling commercial space environment in low Earth orbit, which is only 250 miles above the Earth. To date, there's been a couple of independent sort of commercial flights, but for the most part, NASA is the customer and NASA is the destination with ISS. And so this concept of saying, well, now we've conquered low Earth orbit and that's a thriving commercial space economy is definitely not true. But now extending that to the moon, which is 250,000 miles away, where for sure NASA is the only customer, and for sure NASA's creating the only infrastructure is, to me, a major leap to extending the commercial model to the moon when it really hasn't even been proven out in low Earth orbit.
Going back to one of the other threads from a couple statements ago, you're talking about the commercial aspect, and the commercial aspect has to involve a profit if companies are going to take this on commercially. And of course, to make a profit, you're trying to do things as cheap as possible, which quite often leads to cutting corners and whatnot. So the question I've got about commercial is, would NASA not be better off using the commercial providers cooperatively rather than competitively?
Getting back to the commercial model in general, it not only requires profit, it requires a market and demand, is
Yep.
how I characterize it, and it requires a cost-effective solution. There may be a demand and a market for something, but it may be so expensive that nobody's going to buy it anyhow until it somehow becomes affordable.
Or mandatory.
Right. I mean, that's just for, true commercial business. I think we use the term commercial as a proxy for a contracting method as opposed to, a true commercial environment. I think in some instances, competition makes sense. And I think that'd be in the area where the technology is more mature and perhaps it's an adaptation of a different application to potentially what's of use to NASA. That makes a lot of sense. But where NASA is basically funding the technology development, and when they do it under commercial contracting means, maybe the faster and cheaper way is to just get focused. And I think there's a mix, and I think you have to make the case every time on that. I personally believe if we want to get to the moon, it's got to be a national endeavor. I think there's benefits for international cooperation getting there, and it should be better thought out of what should NASA own and operate and what should they compete. And I think the pendulum's gone too far to one side of buying everything commercial. The other thing we have to consider when you do that is as NASA funds technology development through commercial contracts, and these commercial companies tend to co-fund some of that development. Who owns the IP? Taxpayer dollars are going to create technology, and part of the intent behind NACA, which was a precursor to NASA, and NASA is to help fund technology development for the benefit of the whole industry that could be shared with the whole industry. And are we moving away from that model? And is that a good thing for this nation to do so? And I think that's got to be a consideration as we look at how these contracts are being let.
Yeah, you've actually addressed a point that I was going to ask. When NASA's paying SpaceX billions of dollars and millions more for proving like just in orbit propellant refilling, they're being paid to develop something. Why, at the end of the day, does that product belong to SpaceX and not NASA?
Right. And I think that's a question that should be asked. And I think, having been in private industry where I've co-funded things, I would argue that I own the IP that I co-funded. And and the IP that I co-funded is really the discriminator relative to competition. So there'd be a ways to try and pick what technology you're going to fund yourself to try and get a competitive advantage. But I think that entire model should be questioned because, one of the concepts behind the US government funding this is to benefit industries as a whole, as opposed to single individual companies. The other phenomenon we've seen come out of this is with this private funding, with these quote commercial contracts, as these organizations learn things or have major technical issues, they're not being shared across the industry. And a big part of the success of the space industry has been sharing technical issues for the industry so that any issues that come up, the whole industry can take the lessons learned from that and apply them. Or in many cases, there would be specifications that would incorporate new requirements to take those lessons learned into the specification in terms of certain materials that weren't allowed to be used in certain applications. You shall not, basically, you shall not use this material in conjunction, or you can only use these materials in conjunction with these propellants, that sort of thing. And it will be promulgated through the entire industry, and the industry as a whole, the raising tide would raise all the boats in the industry. Now, as people have proprietary issues, only that company gets to learn from the issues. When I grew up in the industry and as I became a leader in the industry, I would tell everyone mistakes are okay as long as we learn from our mistakes. But it's even better to learn from other people's mistakes. and
That
and
costs
so
you nothing.
constantly be surveying the industry. And there's not as much of that going on right now because people's mistakes are proprietary.
Right now, we do have two competitors in HLS. We've got Starship, which is flying, I call them test articles. I don't even call them prototypes because they're not mission capable and they don't even resemble HLS. They don't resemble a tanker. They don't resemble a fuel depot. They're just hollowed out shells, really. And even the shells are having trouble getting to orbit. And then we've got Blue Origin, who got into the gate late because of what happened with the budget constraints and the dealings that SpaceX made with Kathy Lutters to get that solo option A. But they look like they're on pace to leapfrog Starship with Blue Moon. And I was just wondering if you had any thoughts on that. We've got 4 minutes left in this session.
Yeah, my comment is obviously the Blue Moon looks like a more traditional lander, and I think it is building on prior experience. So I think from a technology standpoint, I think there's still a lot of technology to mature on that particular lander too, but it's not as nearly as large of a leap as Starship is. That lander is single stage, which I think will be challenging to get to the moon versus two stages, and there's a whole conversation around that. And there's a lot of hydrogen involved and hydrogen transfer. So you got this cryofluid management activity. Hydrogen's at minus 423, takes more energy to keep cool than methane does. I know they're working on what they call zero boil off through solar power. And they've also got sort of a transporter vehicle that Lockheed Martin's working on that will have propellant transfer too. So there certainly are non-trivial challenges with their concept too, but those appear to be solvable faster than the challenges that Starship has, is my perception.
We had a question in the queue during that panel about burying liftoff engines into the regolith, two-stage versus single-stage, and I wanted your opinion on that. So I gather you are not a fan of single-stage landers, even though the requirement of Artemis is for everything that lands has to take off again.
Not to start out with, once again, we can evolve to these more sophisticated things, but why make a leap to the most sophisticated thing right at the beginning? In my view, you could have a lander that's hydrogen, which would be relatively efficient, but then have an upper stage and ascent vehicle that's storable, much more reliable. You move the propellants together, they ignite, and you can still have a much higher safety and reliability of getting off the lunar surface back into lunar orbit. That's where I would start with. If you really want to go with hydrogen, I think hydrogen's definitely an option for landing on the moon, but I would really want to see storables for getting off the moon.
Hydrogen seems to be the better option over methane if you're going to do in situ, because you just need electricity and a vessel to separate the hydrogen from the oxygen. But for methane, you need Sabatier process and giant vessels to hold the base ingredients while you're turning it into methane. We're at less than a minute. I'm going to close this session off. And if you're good to go, then I'd love to pick this back up in a part 2.
Sure.
All right, perfect. That's going to wrap up this segment of our conversation with Jim Mazur. And obviously, we covered a lot of ground here. So in part 2, now that we're a little more familiar with each other, we're going to get more into the meat of the discussion and even start talking about some alternative approaches that might be considered if the USA is actually serious about getting humans to the moon before China plans to in 2030. Part 2 will be online shortly with the link right here after it's been uploaded.